To perform extraction to separate out the unknown acid from the neutral compound in our unknown mixture, first label two collection flasks, aqueous and organic, which are the two layers that one is separating. Set up the separatory funnel in the ring clamp secured to the hood bars. One will dissolve the mixture by placing 0.20 grams of the unknown mixture in an erlenmeyer flask, then adding 10 milliliters of diethyl ether, which is going to be our organic solvent, and swirl the flask. The mixture contains fluorine, which is a neutral compound, and will separate out into the organic layer. Then we will be transferring the solution into a separatory funnel and then adding the 7 milliliters of NaOH to deprotonate the acid first, so then the unknown acid can go into the aqueous layer. Then we will be shaking the funnel and then venting every 30 seconds so the pressure doesn't build up, and then the layer should separate into the top layer, which is organic, because diethyl ether is less dense than NaOH, which is the aqueous layer at the bottom. We will drain the bottom aqueous layer containing the unknown acid first, and then by opening the stopcock and removing the stopper so the solution liquid can be released. Then we will wash the separatory funnel with water so then we can isolate any compounds that are still left over in the aqueous layer. Then we empty out the top layer containing fluorine into the organic flask. To isolate the neutral compound fluorine from the organic layer, we add the drying agent to the flask to dry off the solvent and swirl gently for a few minutes. Set it aside for evaporation and then dry it off with air vents if needed. To isolate the unknown acid out of the aqueous layer, we add 6 molarities HCl dropwise into the aqueous layer flask, swirling and testing the pH after every addition. The purpose of adding acid in this step is to precipitate the acid out of the mixture. You know you have added enough acid when precipitate forms and the pH paper is acidic, which is when it's orange or yellowish. Then we will cool the flask in an ice bath for a few minutes, vacuum filter and wash the mixture in ice cold water. Collect the crystal and record the crude mass of the unknown acid. It is important that the DI water is cooled because it will not dissolve the compound and lose any compound in the filtrate. Then we can take the melting point and also do any characterization tests to determine the identity of the unknown acid. Here we are taking the mass of both products, which are fluorine and unknown acid, and then cleaning up by throwing the filtrate into the liquid waste.